Welcome friends to the class of marketing research and analysis. So, we are continuing from the last class where we had left. In the last lecture we had discussed about factor analysis. So, factor analysis is a technique which we have understood that it is a data reduction technique which is used highly all over at least in the marketing space to identify the customer segments, to understand the choice of customers, to price the right to make a right pricing system. So, in psychology also you can see there are a lot of utility of factor analysis. As I had given an example that for example, a psychologist wants to break 60-70 traits of human beings. Traits means the characteristics, personality traits. Now, it cannot understand or explain 60 traits, that is too much, right. So, instead of having 60, if I can have 5 to 6 or 7 or 8 even, right, factors which can represent those 60 traits, then I think it is much useful, it is much better. So, the whole purpose of doing factor analysis is to reduce. So, that is why it is called a data reduction or data summarization technique. Okay. So, we said how do we conduct the factor analysis. So, there are 4 steps. The first step is to draw the correlation matrix. As we have understood by now that the whole the heart and the spirit behind factor analysis is the correlation. There has to be correlation among the variables. If there is no correlation, then factor analysis is not the right tool. Then next is to extract the factors, right. After that, when suppose you do a factor extraction, you find that the factors are loaded into the variables are loaded into only one and one factor mostly, and they are not explaining the other factors well. So, we need to make a structure little more simpler and easy. To do that, we use a technique called factor rotation, which I will explain, right. And finally, we decide the number of underlying factors and we give names to them. So, let us start. So, first step is to generate a correlation matrix for all the variables, right. So, for example, let us say I will just show you, this is a data set I have brought. So, this data set has several variables, let us say the product quality, complaint, advertising, competition, flexibility, sales force image, warranty claims, new products, order billing. It is of a company who is selling products in the market, and it wants to know how consumers are feeling towards, what impression do they have. So, there are several variables, almost 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 variables. So, these 13 variables, some of them might be correlated with each other, some of them might not be, right. So, instead of explaining 13, if we can explain 3 or 4, it is much simpler. So, in such a condition we will go for this factor analysis, right. So, to first thing is to generate a correlation matrix. So, first you draw a correlation matrix. If the correlation between the variables are small, it is unlikely that they share common factors, right. Variables must be related to each other for the factor model to be appropriate. There must be some correlation. Okay. The correlation coefficients greater than 0.3 or 30% in absolute value are indicative of acceptable correlations. Very poor correlations are not acceptable. Okay. That means below 0.3 are not acceptable. Second is this continues, we measure something called a Bartlett's test of sphericity, right. So, what is this Bartlett's test of sphericity? I will do it side by side with you. So, Bartlett's test of sphericity is a technique which tells, it is used to test the null hypothesis. Now, what is it saying? Many people are not aware of it because the XPSS does not explain this. So, you should be knowing. So, it says it tests the null hypothesis that the correlation matrix is an identity matrix, right, and it means what? The null hypothesis that there is some correlation among the variables, right. So, there is some correlation among the variables. So, now suppose you write the null hypothesis and the alternate, how would you write? Now, the null hypothesis is, let us say, we will say no correlationship exists, and the alternate is there is correlation exists. So, in a study for this, what do we want as a researcher? That the Bartlett's test of sphericity should always be rejected, should be significant. Now, let us go back and let me explain this one, the KMO. The KMO is a measure of sampling adequacy. Now, what does it say? The closer the KMO measure to 1, right, it ranges between 0 and 1, it indicates a sizable sampling adequacy. 0.8 and higher are great, 0.7 is acceptable, 0.6 is mediocre, less than 0.5 is not acceptable. So, this talks about whether sampling adequacy is prevailing or it is not prevailing. Reasonably large values are needed for a good factor analysis. Okay. So, okay, let me go to the slide and show you there. This is the one. So, let me run this factor analysis with you. So, you see I am going to dimension reduction factor. Okay. Now, I am taking all these variables. Okay. Okay. So, we have taken all the variables. Now, if you go to descriptives, you will see here the KMO. So, this is what we are talking about, right. So, let us check whether the KMO, what is the KMO and the Bartlett's test, right, the value. So, the KMO is 0.609. So, we said above 0.8 is very good, above 0.7 is good, above 0.6 is acceptable, above 0.5 is acceptable in fact, and this we are having 0.609. That means the sampling adequacy is okay. That means what is sampling adequacy? The number of variables to the number of respondents, the ratio which earlier I had said should be preferably 1:20, right. So, one variable is to 20, you know. So, let me see, let me show you how many variables we have and how many respondents in this case. You see here we have only 100 respondents and we have 13 variables. So, what should be our ideally the sample size? Now, you have 13 variables. So, each variable measured by 20 makes 260 respondents should have been there. Sample size should have been at least 220, 260. If not 260, if you take 1:10 also, which is the minimum, then also it is 130. So, we are still falling short, but anyway there are other factors also which decides. So, overall we will say it is okay, right, because all the studies might not be having large samples, might not be possible, at least as in this case. This is a case of a B2B case, business to business. So, business to customers, for example, in retail mall somebody is standing outside and collecting data is very simple or comparatively simpler, to a case where you are collecting data from an industry which is very difficult to get, right. So, in those cases even 1:5 sometimes is accepted. So, now look at this Bartlett's test. Now, it is 0.000, that means what? The null hypothesis is rejected. So, what was the null hypothesis? That there is no correlation. So, that means now we can say the null hypothesis, the alternative is accepted, which says that there is some correlationship among the variables. So, which is a important requirement of factor analysis. Okay. Now, once we have done that, the second step, we will come to the second step, which is the factor extraction. So, initial decisions can be made here about the number of factors underlying a set of measured variables, right. That means the researcher can decide that how many factors should get generated, but this requires lot of expertise, right. You should not be doing it blindly, that I will say 3 or 4 or 5 without a logic. So, there has to be some theory or some reason behind it why you are saying. So, extraction of factors is possible, that means you can force the computer or the software to give you the number of factors, but then you should know why you are doing it. Okay. Sometimes it is based on eigenvalue, eigenvalue greater than 1, eigenvalue greater than 1 is considered to be acceptable. Okay. Scree plot also I had shown you how it changes. So, from the Scree plot we can say that from after what point the changes are not much. So, we can in one case we saw that there were 3 number of factors which we selected, right. So, if suppose it falls like this and then like this. So, up to this much there is a significant change, here there is no change, right. So, we will say this is the number of whatever the number of factors here. So, 3 or 4 or whatever, right. Estimates of initial factors are obtained using principal component analysis and principal axis factoring. Now, this is very interesting and very important. What does it mean? And what you must have heard the use of principal component analysis very frequently, right. But this you might not have heard much, but if I say use the other word common factor analysis, you might have heard common factor analysis. Okay. So, the principal component analysis is the most commonly used extraction method. Now, what is this method? We will see. Okay. So, what is this principal component analysis? an approach to factor analysis that considers the total variance in the data. So, the variance in the data could be shared variance, unique variance, right. So, we are saying that when you consider the entire variance in the data and then you extract the factors from it, then this method is a called the principal component analysis. This is the basic difference you need to keep in mind, right. It is recommended when the primary concern is to determine the minimum number of factors that will account for maximum variance. Okay. So, minimum number of, so there is a case of parsimony here also. So, minimum number of factors explaining the maximum variance. Okay. What is the principal axis factoring, the other method? So, an approach to factor analysis that estimates the factors based only on the common variance, right. So, it is recommended when the primary concern is to identifying the underlying dimensions and the common variance of interest. So, there can be a common variance which, if there is a common variance and what this was taking total variance and this takes the common variance, right. So, the two methods are slightly different from each other, right. So, this method is the most popular method. This also is used because of its simplicity sometimes. Okay. So, let us see, let us continue with that. So, the principal component analysis, no constructs of theoretical meaning is assumed, simple mechanical linear combination. If you remember in the first one we had said, right, it is the addition of the, let us say the the like a multiple regression combination x1. So, a1 x1 plus a2 x2. So, it is like a linear combination, right. Factor analysis assumes underlying latent constructs. The difference between PCA and FA, you see, is this. Now, PCA, for example, you see what was happening. Now, let us say variable 1, variable 2, variable 3, right. So, so these variables are affecting, let us say, y. Now, in the principal component analysis what is happening? So, this is all affecting y, correct, but in the case of a factor analysis we are assuming that there are latent constructs. Now, I hope you understand what is a latent construct. A latent construct is something which can directly not be measured, it can only be measured with the help of several other variables. Example, what do you mean by that? Let us take a case of satisfaction. Now, how satisfied as a person you are? Now, how do you can I measure satisfaction directly? Not possible, right. So, I will measure satisfaction maybe through several other variables. For example, how satisfied are you in your home, how satisfied are you in your office, how satisfied do you feel when you meet your family members, right, how satisfied you are generally when you are alone. So, when I am these are called latent constructs because they are hidden. So, you want to find out through some way by asking other questions, right, some related questions. Okay. So, allows it assumes underlying latent constructs and allows for measurement error. Commonalities in diagonal of correlation, that means what? When you do a correlation matrix, generally the diagonals, if you see, there is one unity, there is a unity in the diagonals. Okay. But in this case we are saying, because we are allowing for measurement error, the commonalities when will be placed in the diagonal. So, if you think of a correlation matrix, let us say V1, V1, V2, V3, V1, V2, V3, usually what happens? So, this is 1, this is 1, this is 1, but in this case, in a case of factor analysis, this is not that. Here we will place the commonality values, let us say this is C1, this is C2, this is C3. I hope you have understood what is commonality. In the last class I had explained, last lecture. Commonality is nothing but the square of the loadings of a variable across all the factors. So, it was V1 across F1, F2, let us say 2 factors. So, this L1 square plus L2 square is my commonality. Okay. It is also called as common factor analysis. PCA uses the total variance, again I have said this, and derives factors that contain small proportions of the unique variance. FA uses only shared variance, only uses the shared variance. Okay. In most applications, both component means principal component and common factor analysis arrive at identical results. This is very important, please note. In most applications, both component and common factor analysis arrive at similar result if the number of variables exceed 30 or the commonalities for all the variables or most of the variables exceed 0.6. If this happens, then component analysis and common factor analysis, they converge towards each other and they give a very similar result. So, the argument whether I should use a principal component analysis or a factor analysis dies down there, and is of inconsequential effect if you are having a this kind of a situation. Okay. Next step is, how do you determine the number of factors? So, let us go to this one. So, let us first derive the number of factors. Okay. So, what I will do is, we will go to the dimension reduction factor. Now, we will derive the factors. So, I think the factors must have been derived. If you go to the output, now you see, now you can see here how much of variance has been explained in this study. Now, how many, there are 5 components or 5 factors you can understand. So, why it is called components? Because it is the using the principal component analysis method, that is why it is called component, right. So, 5 components are explaining 81.5% of the variance, which is quite good, right. And you can see here the first variance is explaining how much, 27.43% of the variance, the second factor 23, the third factor 13, fourth 9, fifth 7. So, if you go till the end, you will achieve 100%, but then after 5 we are finding that it is significantly dropping down. So, we will say up to 5, if you take 5 factors, then how much are we explaining? If you take a cumulative of this, 81.5. Okay. Now, we have done this component matrix. Now, component matrix, if you see, there are 5 factors have emerged, right, but it is becoming very difficult to analyze these 5 factors in this situation. So, we will make some changes. So, but you can see here 5 factors have emerged, 13 variables, 5 factors. Okay. So, several procedures are used to determine the number of factors. How do you determine? A priori determination, from beginning only through some theoretical backup or understanding you can decide, 1. Second is based on eigenvalues. So, at the moment what we have done is, we have based it on eigenvalue, you can see. So, if you see here, so how it has been selected, right. So, extraction, if you go to extraction, there are 2 you can see here. So, we have used the principal component analysis method, okay, and unrotated factor solution, this is, that means no rotation has been done, and eigenvalue greater than 1. If something, you please understand, this eigenvalue, if it is less than 1, that means the variable is unable to explain for itself even, right. So, minimum at least it should explain for itself, that means it should be at least 1. So, you can have a other fixed number of factors also, which is I said based on your theoretical understanding, but at the moment we have considered that by default is on the eigenvalue, right. So, eigenvalue 1. So, based on eigenvalue which is at least greater than 1. Scree plot also you can do from the graphically based on percentage of variance. Now, for example, you see this is a trade off, the percentage of variance, for example, in this case how much percentage of variance is being explained? Now, the percentage of variance being explained is, let us say, is how much, 81.5. Now, 81.5 is a good amount of variance being explained in the study. Suppose I feel, suppose instead of 5 factors there would have been 8 factors now, and 8 factors explaining, let us say, 81%, and I would feel that 81 is quite high and 8 factors is also too large a number. So, if I reduce it to 6, for example, because of some theoretical understanding. So, if I reduce it to 6, the variance explanation will also go down, from 81 it might come down to 60 or 70 also, right, possibly, or even lower, I do not know. So, you have to check, if you have to do it and check it. So, you suppose take first 6 variables which you feel, and suppose they are explaining you 70%, which is decent enough, not bad. Then you can say here, what you can do is, you can extract instead of eigenvalue you can say 6 here, right. So, this is one thing that you need to understand, but here we are going on the eigenvalue, right. The next thing is, so percentage of variance also you have understood, split of reliability. So, what you do is, you divide the sample into 2, if you have a large sample size, divide it into 2 parts, right, and you find out and you do 2 different factor analysis and look at the results on the 2 different sample groups, and if you find that the factor loadings across both are similar, then also you can understand ki well how whether the study is moving in the right direction or not, right. So, these are some of the ways how you can extract the factors. Okay. The next is factor rotation. So, why you did should do a factor rotation, I will explain. So, let us go back to the data set. So, here first let me show you, here you see when I did this factor analysis, this matrix, right, there are 5 factors, but they are very clumsy to understand, right. So, let us rerun it. So, what I am doing is first I will clean it a bit. So, what I will do is sort by size and suppress small coefficients. So, here instead of having 0.31, what we will do is we will take a minimum, we said the factor loading, the correlation should be at least 0.3, we had said that. So, we will take 0.3, so 0.3, okay. So, continue and we are not changing other things. So, we will just say ok. Now, if you go into this, nothing has changed, if you can see, right, and you see these are the commonalities. Is there anything that is below 0.5 in this case? No. So, 0.5 is the minimum benchmark. If it is less than 0.5 and your model is not very good, then you may start thinking of dropping the one which has the commonality less than 0.5, okay. And but do it one by one, do not, if there are 2 variables below 0.5, do not delete it at once. First delete the lowest value, run it, and if things change for better, it is good. If they do not, then still go for the then next go for the next the lowest one again. Now, look at the component matrix. Now, if you see, now it looks little cleaner than the earlier one, but still there is a problem. I see that most of the variables are loaded and there is a lot of cross loadings. Can you see? For example, Salesforce image is cross loaded on 4 factors, some of them are loaded onto 3 factors, some are loaded into 2 factors. So, cross loading is again a very dangerous thing, right. Cross loading is very dangerous. So, we should try to avoid cross loadings, and if cross loadings do not go, then that variable may be as an item for deletion, okay. So, now we will go for a extraction method, right, rotation method. So, by rotation we may think of improving our model. So, let us go to rotation. So, the most popular rotation is Varimax rotation. Now, first let me run it and then I will go to the before that I will show you the first the theory. In this step factors are rotated, right. So, as we just did the Varimax rotation, factors are rotated to make them more meaningful and easier to interpret. So, as I said, suppose let us say the the variables are the data points are like this, okay, right. So, we can see suppose this is let us say it's a factor 1, this is factor 2. So, most of the variables are these are the variables, right. So, V1, V2, V3, V4, V5 they are mostly loaded into the first factor, right, and because they are close to the factor 1. But suppose we tilt it a bit, we tilt it, what we will do? We will tilt it a bit on a 90 degree, keeping this 90 degree. So, this is 90. So, what is happening now? We can see that some of the variables like for example, V1 and V3 will go to factor 1, but V4, V5 may come down to the factor 2, right. So, factor rotation only does this work, it makes it more easier to interpret, right. So, different rotation methods are there and they result in the identification of the different factors. So, 2 broad categories are orthogonal and oblique. Orthogonal is when it is 90 degree. So, when it is 90 degree means what? The variables are uncorrelated. So, one variable is going this side, the other variable is going this side, they are not correlated at all. But oblique rotation is something where you see there is I have brought it. So, major types of rotation orthogonal, the resulting factors are uncorrelated, right, the major resulting factors are uncorrelated, right. So, there is a 90 degree. It is more parsimonious and efficient, but it is less natural. In a social science, just imagine which is on human relationships, how do you feel ki 2 factors will not be correlated? There will be some correlation, but it is easy to interpret and easy to conduct, right. On the other hand, oblique rotation is where resulting factors are saying it is correlated, that means the factors are correlated, but for a mathematical understanding and a theoretical understanding we will say that they should not be correlated, right. But in truth correlation between the factors will surely exist. So, you see the angle is less than 90 degree in this case, right. So, that means what? So, at some point of time they will converge somewhere, right, but it is a very complicated technique, right. Anyway, so orthogonal rotation, there are two, basically Varimax and Quatermax, but Varimax is most likely utilized, and among oblique it is Oblimin and Promax, there are two methods. And generally what we have seen in factor analysis, we have used, you may try using, according to your logic, you may use the oblique rotation also, does not matter, right, and you will see if there is any change for the better, theoretically the explanation is getting better, it is much good, right. So, let us take let us go back to the data set, the output now. Now, we have done some rotation, correct, and the variance does not change, nothing changes, right. So, this was the component matrix, and now let us look at the rotated component matrix. So, you can see there is a C change, there is a big change, right. Now, for example, you see, so now most of the variables were loading into here, right, here, and there was a lot of cross loadings, can you see. Now, these cross loadings are somewhere gone, disappeared. Now, you see it is very clear, the first factor has got 1, 2, 3, 4 and 5, okay, although there is a cross loading in this case, right, but does not matter, it is much better than the earlier one. Factor 2 has got 1, 2, 3, 4, factor 3 has got 1, 2, 3, 4, this is something similar, right, and last factor has got only 1. So, anyway, so we have understood by now that when we do a factor rotation, the factors are equitably or in a distributed in a much better way, and their explanation power improves, okay. Well, what I will do is we will continue from here, then we will go into the next things, right, about rotation, and then how to check for after rotation we have to make a final decision, and then we have to check for reliability and validity, and how to utilize the outcomes or the results that you derive from factor analysis for other studies, right. So, we will do that in the next lecture. So, today I think you are clear with what is factor analysis and how to conduct a factor analysis. So, step by step I have tried to explain you. So, we will proceed similarly in the future in the next lecture, and we will finish there, right. Thank you so much.